this video, we are going to be solving word problems. All right. Our favorite superhero, Mr. Helpful, Not Hurtful. If you're unfamiliar with who that is, definitely check him out on YouTube. He's the best math teacher ever. He's on the case again and is trying to save Miss Porter, who has been taken hostage by the Sinusoid boys. Mr. Helpful, Not Hurtful has trampoline boots and is bouncing up and down in front of a window to assess the situation. His line of sight, the height of his eyes in inches, can be modeled by the equation given. Negative 48 cosine 2 pi over 5 times t plus 120. The bottom of the window is 120 inches above the ground, and the top of the window is 180 inches above the ground. At what times will Mr. Helpful, Not Hurtful be able to see the window within the first 30 seconds of bouncing? All right, so let's see what we've got here. And courtesy of Matthew Augustin, I have this drawing. No, I am not capable of drawing this. As you guys should know, if you are one of my students, you know I can't draw to save my life. So here's what we've got right here. We've got Mr. Helpful, Not Hurtful bouncing up and down on the ground outside of a window right here. He's using his trampoline boots that he's got right here. And let's go ahead and label the points that we've got. The thing that we have here is that the bottom of the window is 120 inches above the ground and the top of the window is 180 inches above the ground. So let's label that. There we go. That's labeled. So we have 120 inches as the bottom, 180 inches as the top. So basically what we're just trying to see is as he's bouncing up and down on our or in front of the window, we're trying to see as his eyes are looking in the window whether or not he's actually high enough to see within that. Okay, so let's see what that would look like. So let's just kind of draw a little bit of a model of what that graph is going to look like. What this is saying is that he's jumping up and down in front of the window, and the bottom of the window is 120 inches above the ground, and the top of it is 180 inches. So basically what I'm looking at here is the window, the very bottom would be at 120 inches above the ground, and the window would be at 180 inches above the ground, okay? And so as I'm going up and down, up and down, up and down in front of that window, we're just trying to see what we've got. Now, if the equation that we have is as what is given, which is the height is a function of time, so as our time progresses, our height is going to change. They're related to each other. And it gives me this negative 48. Now remember that that's going to be your amplitude, so that's telling you that you're going above and below whatever the midline is by 48. And in this case, our midline is 120, okay? So that means that if I'm going up and down, I'm going, well, I guess what I'm looking at here is that I'm going to be going 120 plus 48 and 120 minus 48. So that minus 48, that's going to give me the very bottom of his line of sight. So that would be as if Mr. Helpful, Not Hurtful was just standing there and looking straight ahead. And then our 120 plus 48 would be the absolute peak of where his eyes would be. So let's go ahead and label those. Here we go. So we can see 120 would be the bottom of the window and 180 is the top. So this is what we've got here. And then, so if I do that 120 plus 48, I get 168, and 120 minus 48, I get 72. So that means that as Mr. Helpful, Not Hurtful is jumping up and down, the highest he's going to go is 168 inches, and the lowest would be 72. So he's never jumping above the top of the window, at least. So from here, we're going to go ahead and kind of model this as a cosine graph. Now, keep in mind that this is cosine and it's got a negative a. So that means that it's starting at a minimum. It is not starting at a maximum. So let's go ahead and kind of draw some sort of shape for what we. All right, so let's go ahead and do this. Here we go. All right, so this is right here showing us that at the very bottom, it's at 72. At the very top, it's 168. And then we've got our midline at 120 inches. So basically, that's what we're looking at here, and then we're just trying to solve for what we've got for this entire thing as we're continuously doing this for 30 seconds. So another thing that we have to realize in this question is, what is our period? So here we're given that the period, or actually not our period, but we have our b value is 2 pi over 5. Remember, in order to get your period, it's 2 pi divided by b. So in this case, I'm going to do 2 pi divided by 2 pi over 5. And so that's going to go keep, change, flip. And when I do that, the 2 pi's are going to cancel out. And that tells me that he's going from the bottom to the top and back to the bottom again. So he's doing a whole bounce every 5 seconds. So we're going to have this repeating 6 times over 30 seconds. And I know that simply because, 30 divided by 5 is 6. So that's what I'm going to go ahead and do. And now I need to figure out what are the times going to be when he's doing that, because that's what it's asking me. At what times will Mr. Helpful Not Hurtful be able to see into the window within that first 30 seconds? So if we start at 0 seconds and go to 30 seconds, how often are we going to be looking here? So let's see what we've got. So if I take the equation that I was given and I go ahead and set this up, what I'm needing to know is when he is jumping up and down, and he's able to see inside this window. So that means that I need that height to be greater than 120, but less than 180. Well, we know it's always going to be less than 180 because that's going to be right here. We've got that 168 as our maximum, but it is not always going to be above 120. So really what I'm solving for when you're looking at what you've got here, I'm looking for all the times where I'm going to be here to here. And let's color that in. So that would basically be going from that point to that point on repetition, okay? So let's figure out where that's going to be located. Now, I know the height, but that's not what I'm solving for. It's asking me at what times. So remember that this is height as a function of time, so that means that time is going to be my x-axis. So I'm solving for what are those x-coordinates when I'm right there, okay? So as I go through and go ahead and solve this, I have to remember one thing, okay? I'm doing an inequality because I'm asking at what time is my height at least 120 inches. So I've got 120 inches, and I need that to be less than or equal to what I've got from my equation, because 120 inches is the bottom of the window, okay? So I'm going to go ahead and solve my equation for what I've got right here. So my first step in an equation like this is to go ahead and get it set equal to 0. So I'm going to subtract 120 from both sides. And that's going to get me that 0 is less than or equal to negative 48 cosine 2 pi over 5. Oof, what in the world? I don't know why my 2 just turned into a 0. All right. And then now that 120 is going to cancel out. So this is what I've got now. Okay, so this is no different than anything else so far that we've been doing. And now I've got to go ahead and get my trig function by itself. So that means that I got to get this negative 48 over to the other side. So let's go ahead and do that. So when I do that, I got 0 divided by negative 48. Well, 0 divided by anything, it's still going to get me 0. And I am dividing by a negative, so that means that I need to change my sign. All right, and so now I'm going to have 2 pi over 5t right here. And so now what I'm solving for is when is my cosine inverse equal to 0. What I'm going to go ahead and do here is I'm also going to go ahead and at this point, because I'm doing the inverse, I'm just going to kind of change this into an equal sign for right now. It's just going to make things a little bit easier for myself, and then we'll go from there. So right here, where is cosine equal to 0? Well, it's equal to 0 at pi over 2. It's also equal to 0 at 3 pi over 2. So I'm going to go ahead and set that up. So I've got 2 pi over 5t, and then that's on both sides. Okay, so now if I'm to solve for t, that means I've got to get rid of that 2 pi over 5. I've got to get it over to the other side. So in order to do that, that means that I would multiply by the reciprocal to both sides. So I'm going to have 5 over 2 pi multiplied out on both sides. And I'm going to do that to both equations because that's going to get that 2 pi over 5 over to the other side on both equations. So here that's going to cancel out, and same thing here, it's going to cancel out. But on this left side of both of these equations, it's going to be a little bit different. So the pi's will cancel out, so I'm going to have pi canceled here, but I'm still left with the 5 and the 2 and the 2. So this is really going to be t is equal to 5 over 4. And then over here on this side, again, the pi's are going to cancel out, and I'll be left with 5 times 3, which is 15. And so I'm going to have 15 over 4. So this is what I'm going to have. 5/4. I don't want to say 5/4 of a second. But essentially what I have is 5/4 of a second and 15/4 of a second is where Mr. Helpful Not Hurtful is going to be able to see in the window. So this is what we have here. These are going to be our x values that we just solved for that first period. So out of 30 seconds, if he has a 5-second period, that means that, again, we're going to take that 30-second interval and go ahead and divide that up into 6 different periods where he's going to be able to see in the window. And so this 5/4, that's equal to 1.25. And then the 15 out of 4, that's going to be equal to 3.75. So that's what we're saying, is that 1.25 seconds and 3.75 seconds, between there is when he can see inside the window. So that's our first interval, and so then we're going to find all of the rest of our intervals. So I'm going to go ahead and do that. So if I have this here, I'm going to say my very first one, that's at 1.25. And then my second one, that one's going to be at 3.75. So he's going to be able to see in the window there. And then I'm going to find my next interval. Okay, so if you think about it this way, this is my 60 seconds, or not 60 seconds, my 5 seconds of my first period, okay? And then I'm going to have 6 more, or 6 total, okay? Would see. This is where he would be bouncing up and down over and over, right? And so here he is bouncing up, top, down. And this is over the period of our 30 seconds, okay? And so here's our 5 seconds. So then this means this is 10, 15, 20, 25, and then 30 seconds, okay? What I just solved for, this 1.25 and 3.75, is where he can see inside the window. So that would be like, let's say from here to here, okay? I found these points. I need to find these points again and again and again and again and one last final time. So if you think about it this way, this one right here is 1 period less than this one. So basically all I need to do is find that first one and then just add my period and I'll get this one. Same thing, take my second one, add my period, and that's going to get me my end of that one. And then I just keep on going. So if you recall earlier, we found our period was 5 seconds. So I'm just going to keep on adding 5 seconds. So 1.25 plus 5 is going to get me 6.25. 3.75 plus 5 is going to give me 8.75. And there's my next interval. Now I got my next one. So 6.25, and I'm going to go ahead and add 5, and that's going to get me 11.25. And 8.75 plus 5, and that's going to go ahead and get me 13.75. Okay. I'm going to kind of do the continuation down here. And then I'll have 11.25 plus 5, and that's going to get me 16.25. And then 13.75 plus 5 would be 18.75. Almost made that as a parenthesis. Bracket. 16.25 plus 5 is 21.25. Not 5, 2, 5. And then I've got 18.75 plus 5, and that's going to get me 23.75. Keep on going. So 21 plus 5 is 26.25. And 23.75 plus 5 is going to get me 28.75. Now, if I add 5 to 26.25, that's going to get me 31.25, which is outside of that first 30 seconds. So these are my first 6 intervals where he can see inside the window. And that matches up with exactly what I said for it being 6 intervals and that it's got to be less than 30 seconds. So those are my times that I've got for this one, okay? All right, let's go. We're going to try this one now. So this one right here, it's a little bit different. It says that it models the distance in millions of kilometers, the equation that I'm given, from Venus to the sun, T days after its furthest point from the sun. How many days after passing its furthest point does Venus reach 220 million kilometers from the sun? Well, one of the things that I really need to take note of is that it says that this is calculator active. And so this means that I can go ahead and practice using my calculator on this problem, and it's going to make my life so much easier. So let's go ahead and get out our calculator. Pulled out the TI-84, and we can go ahead and start entering our information in here. Remember that what I'm going to be doing now is I'm going to be entering the entire equation as it's given to me here on the right, and then I'm going to be setting the second equation equal to something. So here we go. We're going to go ahead and do 21 cosine. And then I'm going to enter everything that's in here. So I've got 2 pi divided by 725. And that's times t. Well, I'm just going to use x because that's my variable, plus 228. So that's going to be my first equation that I'm putting in here. The second equation is what I need it to be, and that's where it's equal to 220 million kilometers from the sun. So let's go ahead and do that here. So I'm going to say 220 equal to, and now I'm going to graph it. Oh, but wait, that's not going to show up in my graph. The reason it's not going to show up in my graph is because I've not adjusted my window. So if I look at the window that I have set up in here, it's currently set up with pretty much what I believe is your standard window, where it goes from -10 to 10 on both your x and your y axis. Well, obviously, I can't do that on this one, because if I think about it, that 228 is that midline, and the 21 is my amplitude. So that means that I'm going to have my y values are all going to be between that 228 plus or minus 21. So that means that the y-axis, oops, I don't know, just click. So the y-axis actually needs to be set for a minimum of 207 and a maximum of 249. That's going to go ahead and get my y values to be visible, and then I need to change my x values. I want it to be at least for just one period. And so let's go ahead and look and see what that would be. So if I started at 0, that would be my x minimum, and my x maximum would be whatever the length of a period would be. Well, in this case, I don't know what my period is quite yet. I have to do a little bit here. So I have 2 pi divided by b, and in this case, b is 2 pi over 725. So when I keep change flip, the 2 pi's are going to cancel out, and I'm going to be left with 725. And so in this case, it's days. So 725 days is going to be what I'm looking for here, okay? We're going to enter 725 as our x maximum, 725. And obviously, I don't want my x scale to go by 1. If I'm going from 0 to 725, I need it to be something reasonable. So actually, let me do it in 25s. We'll do it by 25s. And let's graph that. Well, now we can see the whole thing. What I'm trying to figure out here is where this point is going to happen. And so it's got to be at this intersection point, okay? And so in order to do that, I have to now go ahead and do my tracing, or really I'm going to do second calc. I'm going to find where these two equations intersect. If you need help doing this, please refer back to my 3.10 day 1 video. It's going to be right at the end. And I've got the intersection right here is 226.34639. And so that tells me it's going to take 226.346 days. So let's write that down. That's what we got, 226.346 days. Hooray, that was easy. All right, so now we've got this next one. I got another wonderful illustration here from Mr. Matthew Augustin. All right, so what we've got here, it says, as a buoy floats in the ocean, it cycles between 2 feet above sea level and 2 feet below sea level every 3 seconds. So assuming you start a stopwatch when the buoy reaches its maximum height, for what intervals of time would that buoy be at least 1 foot above sea level? And so what I'm happy to do is kind of figure this out. So we can see the buoy is just kind of floating in the water there, and it's going to be going up and down as it goes, and it's kind of going to be taking that sinusoidal curve that we're looking for here. So let's go ahead and draw a little simple idea of what our graph is going to look like. Here we go. In this particular case, what we're going to go ahead and do is just kind of show that it's going to be going up and down for what we've got here. So sea level would be 0. And then if it's going 2 feet below, that would be negative 2 feet, and 2 feet above, that would be positive 2 feet. It says that it's going to do that every 3 seconds, where it goes between a maximum, so going from 2 feet above to 2 feet below every 3 seconds. So if I do that, this would be 3 seconds, and then that means it goes from the bottom to the maximum, another 3 seconds. So our period here is a total of 6 seconds. Okay, now in order to solve this, what I'm trying to figure out is what intervals of time is the buoy going to be at least 1 foot above sea level. So what I'm solving for is this 1 foot right here. I want to know between this period and here, what I've got right here. That's what I'm trying to figure out. Okay, so I've got to figure out where this intersection occurs, and then I know also where it ends, because obviously it's going to end here at 0 and it's going to end here at 6, but it's going to really technically, it continues for my next period, and that would match right here. Okay, so let's go ahead and solve for what that point is. Now, in order to do that, I must recognize that this says that it's calculator active, so that means that I'm going to be able to plug this into my calculator and solve. I'm not given an equation in this case. I have to create the equation. So let's go ahead and think about that. So with what I've drawn here, I've drawn cosine, correct? So let's go ahead. I've got cosine. We know that our amplitude is 2. This starts at a maximum. It doesn't start at a minimum, so it's a positive 2. My period is 6 seconds. So that means that I'm going to do 2 pi divided by my period, which is 6. And this is going to reduce down and get me pi over 3. So that's what my b value is. So I have pi over 3 x. Well, I'm not going to use x. We're going to use t. Okay. And is it going up or down? Have I shifted my graph up or down at all? Have I shifted it left or right at all? No, I have not. So this is the equation that I'm going to use, and that's the equation that I'm going to put into my calculator. I'm going to enter in 2 cosine, and then it's pi over 3 t. And then what I'm going to set the second equation up for, I want to know when it is greater than 1 foot above. So I'm going to set this equal to 1. Now I need to adjust my window on my calculator. So think about what we need. So our x minimum 0, that's a reasonable one, but my x maximum, I don't need 725. The period that I have for this particular one, we already determined was 6 seconds. And then my x scale, I need that to go back down to 1. Basically what that xCl and the yCl represent is just the scale for each one of your tick marks on your x-axis. And then what I would want from my y minimum would be -2, and my y maximum would be +2, because that's what my graph is going to be cycling between. And if I graph it, I have one cycle of my graph that I have right here. So now I can go ahead and figure out where those intersection points are. And so I've got my first curve, second curve, and then it says for me to go ahead and guess. I'm going to move my point over here. And so I've got my first one. Well, it's right here at 1. Okay, cool. That works. So it's 1 second when it's right there. So I've got time equals 1 second. Oh, I'm not going to use that. I'm going to say that one. And then I'm also going to solve for this one right here. So if that was 1 second, this is 1 second right here, I've got to figure out what's this one going to be. And so I can go ahead and calculate that. I'm going to do that by doing my second interval, or second trace, and going to intersect. And so now I'm going to go ahead and scroll right on over here to my other intersection. And I get 5. Okay, so 5. So at 1 second and 5 seconds, that's what I've got right here. So basically, what I'm going to go ahead and do is I'm going to write this in a set of intervals that I'm going to go ahead and do here. So we're going to have our height is greater than or equal to 1 foot at the intervals of t being equal to 0 to 1, and then from 5 plus 6k. And then I'm going to do my next one as where does this interval end? So actually I've got to do a little bit more and figure out where does this end into my next part that I've got right here. And I can find that by taking this interval that I've got right here, this 1, and let's just add the period to that. That would be 1 plus 6k. And so that just gives me 7. So it's going to be 7 plus 6k. And this is, of course, where k is an integer. Okay. Now, the reason why I have to do this second one like this is because the first one right here, this 0, is starting in the middle of that interval. It's starting right here. So I can't just go 0 plus 6k to 1 plus 6k because that's going to leave off this part right here. So I've got to figure out what this one would be and then find my next entire whole period where it's going, or I shouldn't say period, but my entire whole interval where it's going to be greater than 1 foot. And that's what I'm going to do for that. So this right here would be my final answer. Hopefully this helps and makes a little bit more sense for y'all.